Structural rehabilitation. The whole weight of the building comes onto the beams, which is transferred to the ground through its columns. Hence, the beams and the columns are the most important part of the building, as they carry the total load of the structure. Failure of these will result in the collapse of the building itself. The main reinforcement of the beam is at the bottom, and the main column reinforcement are at its periphery. These reinforcements often get corroded because of ingress of corroding elements from the atmosphere in the presence of moisture. When the steel corrodes, it expands many times its original volume. The onset of corrosion in the building can be diagnosed from the presence of cracks and swellings in the areas of the beam and columns where steel reinforcements are expected to be there. The cracks such as these suggest an advanced stage of corrosion. Buildings in the coastal region are subjected to corrosion faster. Careful removal of the cover concrete after providing adequate supports whenever required exposes corroded steel which comes out, reducing steel from its original size. Such buildings are unsafe for living as they can collapse any time. Such buildings can be rehabilitated by re-strengthening and made worthy of living once again. This rehabilitation process involves careful removal of cover concrete from the reinforcements to the extent it is corroded, and cleaning them with wire brush. Additional reinforcements are added and welded to the existing reinforcement to make good the loss of steel, which is lost in corrosion. The main chemical used in rebuilding and repairing this kind of damage is Permabond SBR. SBR stands for styrene butadiene rubber. This is a milky white liquid which is indispensable in rehabilitation of corrosion-damaged structures. Permabond SBR is mixed with cement in the proportion of 1:1 by volume. Here, 2 measures of SBR is mixed with 2 measures of cement. This slurry is brush applied on the cleaned, sound reinforcement and onto the added reinforcements if any. This coat acts as a passivator coat or a coating that prevents further corrosion of steel in future. After this passivator coating dries up, say after an hour or so, the concrete surface is made good with a mortar, prepared by mixing 1 kg of cement, 2.5 kg of Zone 2 sand, 200 ml of Permabond SBR and 150 ml of water. This mortar is applied on SBR and cement slurry applied all over the broken concrete and the reinforcement as a bond coat. The mortar is hand-packed in layers of 20 mm. Further build-up is achieved in layers of 20 mm build-up on mechanical key, created on the first mortar layer when it is still soft and on the fresh bonding slurry applied. This mortar is usually strong than the parent concrete.